Okay, section 4.4, solving problems using obtuse triangles. So they've given you just a little organizer here in your book. It says, keep in mind that you can use the following decision tree to help choose a strategy when solving problems that involve tree. So first of all, you always should draw a diagram. There's no way to solve these without drawing them, so you have to absolutely draw a diagram, and that's a lot of what's going on in these lessons, is you trying to determine what the triangles look like. And then you should obviously label it with all the given information. If it's a right triangle, they suggest that you use the primary trig ratios. Lots of you love the sine law, so you don't necessarily have to use the trig ratios. If you want to use the sine law, you're allowed. But I find that in a right triangle, the trig ratios, sine, cosine, and tangent, are the quickest and most efficient way to calculate unknown sides and angles. If it's an acute triangle, meaning it's not necessarily a 90-degree angles, use sine or cosine law. And obtuse triangles, you only have the choice of sine or cosine law. So there's two examples here that we're going to go through, and again, it's all about finding the picture. Okay, so we're going to try to draw the picture and then use it to solve what we need to know. So this example number 1 says an aerial cable car takes passengers across a 74-meter wide gorge. At one point in the crossing, the angles of depression of the cable supporting the cable car measure 43 degrees and 37 degrees. Determine the length of the cable to the nearest tenth of a meter. Remember, nearest tenth means to 1 decimal place. All right, so this is sort of what I see. If we have a gorge, it means that there's 2 mountain tops going on. And then if we have a cable car, there it is. Okay, that's the best you're going to get from me. It's going to be supported by 2 wires. So there's 1 wire, and then there's the other. Okay, so this cable car is obviously going to travel along the wire, but as it travels along, it's going to create 2 lines. Okay. Now it says at one point in the crossing, the angles of depression of the cable supporting the cable car measure 43 and 37. So imagine a straight line across the gorge right there. Okay. Angle of depression is always from the horizontal down. So when it says that it's creating angles of depression, it's not here, it's here, with the horizontal going down. So 1, we're going to call 43. Come on, that's 43. And let's call this one 37. Okay, it doesn't matter what side it's on. And it does say that the gorge is 74 meters wide, so 74 goes here. And it's asking to determine the length of the cable. So it wants to know the entire green length, but remember, which is in 2 sections here, because the cable car would be weighing it down. So it's wondering what's the length of this and the length of this, and then we just add them together and we have the total length. Okay. All right, so look at what we have. We've got 2 angles. This is a 43. This is a 43, that's a 37, and we know that's 74. So if we look at our triangles, I wouldn't suggest trying to make them into a right angle triangle, because you have no idea once you split. Like if you tried to draw that 90-degree height, you don't know where it splits at 74. Okay, so remember, to use sine law, we have to use a set. So we don't have a set because we don't have this angle on that side. We don't have that angle on that side. We have this side, but we don't have this angle. But we can easily calculate it because remember that angles in a triangle add to 180. So this angle here is 180 minus 43 minus 37, which works out to 100 degrees. And now we have a set, which is nice because now we can use sine law. Okay, so let's call this x because we have to call it something, and let's call this yy. And we're going to set up our sine law. So we're going to say the sine of 100 over 74 And let's pick the right side. Equals the sine of 37 over x. Okay? Sine of 100 over 74 equals the sine of 37 over x. I can also say the sine of 100 over 74 equals the sine of 43 over y. So let's go ahead and set that up as well. Sine of 100 over 74 equals the sine of 43 over y. Okay? So on this one, I'm going to go 74 times the sine of 37, divide by the sine of 100 to get x. It asks for the nearest tenth. My answer is asking me to round to a nearest decimal, but I have two numbers here that I need to add together, so I'm going to hang on to 3 decimals just to make sure that I'm rounding properly. So on my calculator, I'm going 74 times the sine of 37, I'm dividing by the sine of 100, I get 45.221. Where's my phone? Make sure you can get that on your calculator. Okay, over here, y is going to come from 74 times the sine of 43 divided by the sine of 100. $51.246. Add them together. I get 96.46. 7. So to the nearest tenth, the wire is 96.5 meters. Okay, I think you can handle that. You've done questions like that before. I don't think that one should cause you too much grief. Example number 2 is sort of difficult because it's a 3-dimensional. We're used to doing questions that are sort of 2-dimensional like this. It's quite easy to do that. This one's 3-dimensional, so I'm going to skip this question, and I'm not going to require you to do any questions like this. So if you want to try it and come up and see if you got the answer right, please do so, but I'm not going to evaluate you on being able to do questions that are 3-dimensional. So that's the end of this lesson. Go ahead and try homework.